Alright, this is a review video quickly on some geometry related quadratic application problems. These are the ones that typically involve sometimes area. So let's do number one. The width of a rectangle. So if we go back and review, a rectangle is usually longer than it is wide. So I'm going to label this length and I'll label this width. The width of a rectangle is. So it's basically talking about the width is. Okay, width is my equals. 6 meters less than. So I'm going to subtract 6 from its length. So length minus 6. The area of a rectangle is 112 square meters. So length times width of a rectangle equals its area. Okay. So the length is going to be L. The width is actually represented by L minus 6. And it equals the area equals 112. So if I work this out all the way, okay, we're basically looking for two numbers that are 6 numbers apart that multiply to give 112. There's a chance that if you can guess and check, you might actually figure out the answer without doing this lobster claw and solving step. But if not, L squared minus 6L. I'm going to bring 112 over here, and it's going to become minus 112, because when I solve for quadratics, I usually have to set them equal to 0. These should factor, so I'm going to ask myself what multiplies to give 112 that subtracts to be 6. All right, I think it's L times L, and I think 14 times 8 multiplies give me 112, and it does subtract, because this gives me a hint that I'm going to subtract to give me 6. The bigger number wins the sign, so negative 8, so positive 8, negative 14. Now, when I split and solve, I turn out to have my length could be 14, or my length could be negative 8. We are not going to deal with negative lengths, so in this particular problem, we're going to discard the negative 8, so the length must be 14. Now it asked me to find the dimensions of the rectangle, so I not only need the length, I also need the width. So I would simply say, well, the length is 14 minus 6, which means it's 8. This is an 8 meters by 14 meters rectangle. Okay, so that would be my dimensions. Number 2, the dimensions of a square are altered, my bad. So let's start with the square. And the thing about a square is you would have a length. So this would be like x length by x length. They're altered so that one dimension's increased by 7 feet. So I'm going to take this one here. It's basically like I'm going to add on 7 more feet. So I'm going to add 7. Okay, and that's going to make a bigger space. The other is decreased by 2 feet. So it's basically like I'm going to take 2 feet away. So I'm going to subtract 2. So now I have a different shaped space. It's now changed from a square x by x to a rectangle that's x plus 7 times x minus 2. Okay, because this now is gone. I subtracted the 2 away. The area of the resulting rectangle, well, the length times width is equal to the area. The length is now x plus 7. The width is now x minus 2. And the area is 90. These two are basically 9 units apart. Plus 7 minus 2. X and x. Okay, so I'm going to get x squared plus 5x minus 14. And then I'm going to go ahead and bring the 90 to one side so that when I solve, I end up having everything equal to 0. So I'm going to have to factor x squared plus 5x minus 104. So I need to figure out what multiplies to give 104 that subtracts to be 5. Multiplies to be 104 that subtracts to be 5. Alright, I did work a little bit, but I think if you try 13 times 8, 13 times 8 is 105. And the bigger number wins the sign, so I get a positive with 13, the negative goes with 8. When you split and solve, the x could be negative 13. I know we're talking about dimensions, so I cannot consider negatives. The other one is 8, so it must be 8. It says find the original area of the square. So my x is 8. And if we go back to look, that was originally, it must have been an 8 by 8. So if we added 7, it changed to 15. And now take away 2, it changed to 6. So that is the new size, 15 by 6, but the original would have been 8 by 8. So an 8 by 8 would give me an area of the original of 64 square feet. Area is always in feet square because it's really 8 feet times 6 feet. All right, number 2. Let's talk about number 3, the shorter leg of a right triangle. So this one's different. So short leg of a right triangle. So if I take a look at this, here's my right triangle. This has no question. It has to be labeled hypotenuse. These are both called the legs. Okay. Obviously, this one on the left, it would be my short leg, and this one on the bottom would be either be the longer leg or the medium-sized side. Okay. The shorter leg of a right triangle is 8 less than the hypotenuse. Okay. The longer leg is 1 less than the hypotenuse. So I'm going to let the hypotenuse be length x. So the shorter leg is 8 less than the hypotenuse, so x minus 8. The longer leg is 1 less than the hypotenuse, so x minus 1. Find the perimeter of the triangle. Now, what I have to do is I have to relate all these sides in some way that they go together. So what I end up needing to do is I need to remember the Pythagorean theorem. Okay, let me redo that. The Pythagorean theorem. The Pythagorean theorem says that in any right triangle, if I square the hypotenuse, so it's basically c squared is equal to a squared plus b squared, where c is the hypotenuse. Okay, in my problem, the hypotenuse is actually side length x. Well, it's equal to the other two sides that are squared and then added together. Well, it doesn't really matter which one's a or b, so I'll let this be x minus 8, and I'll let this be x minus 1. All right. I have to go back and remember that that really means 2 parentheses alike. 2 parentheses alike. Okay, and then of course I'm adding. Okay. So if I multiply this, I believe I get x squared. I do have a middle term. That's going to be twice negative 8, so it's negative 16, positive 64. I'm going to get over here x squared, negative 2x, positive 1, with a plus in the middle. Okay. And then, of course, it's all set equal to x squared. I need to move everything to one side. And if I do that, I need to set it equal to 0. So here's what I'm going to do. I'm going to move this over here. I'm going to subtract x squared, which is going to take this away, and I'll have 0 equals. Now, x squared minus x squared means that's gone, but I still have a positive x squared remaining. So that's going to be x squared. Now I'm going to find my like terms, and I'm going to add them. Negative 16x, negative 2x turns out to be negative 18x. Positive 64, positive 1 turns out to be plus 65. So now I'm down to the point where I think I have it more manageable. It looks like a regular trinomial. I've combined everything I can. So I get x and x. What multiplies gives 65. That adds to be 18. I believe 13 times 5 does give me 65, and 13 added to 5 gives me 18. So I believe it's 13 and 5. And again, it would be negative and negative. That adds to be negative. Now, if I split and solve, I get x is equal to positive 13 and x is equal to positive 5. And here's my dilemma. They're both possibly going to work. Or are they? Well, if I let x be 5, what if I let x be a 5? Okay, only one set of these numbers should work. So if x is a 5, well, this side's 5. But what's 5 minus 8? That doesn't work. 5 minus 8 is negative 3. You can't have a negative side. So for that reason, 5 is just too small. So it turns out that the side that works is, this side has to be 13. So x is 13. This is going to be 13 minus 8, which is going to be this shorter side is 5. And this would be 13 minus 1, which is 12. Now it actually says find the perimeter of the triangle. The perimeter of the triangle would be simply add them all up. 5 plus 12 plus 13. And so basically I get 5 plus 12 plus 13, 25, 30. The perimeter of that triangle turned out to be 30. Again, not a super common problem, but one that you might want to review before you let this section go. We would have done these in Math 1. Okay, number 4, last problem. Given the diagram below, find the area of the shaded region. The shaded region. Okay, notice that this looks like a big box, but then there's a smaller box, and it looks like it's a donut, like the small box is taken out, and everything that's on the outer edges, this part right through here, this is the shaded part that we're interested in. Okay, so we're interested in that shaded region. So I need to take the area of the big, and I need to subtract the area of the what? Very small. If the area of the shaded region is 103, so the area of the shaded region is what I'm interested in. Says the area of the shaded region is 103, so 103 must go here. Well, how do I get the area of the big? Well, the area of the big is 3x plus 2 times x plus 3, or x plus 6. I must multiply those. So it's going to be 3x minus 2 times x plus 6. Okay, and then I want to subtract the area of the small, and the small one is x plus 1, or x minus 1 multiplied by 2x, and I want to write it that way. Now what I need to do first is I need to get rid of all my parentheses. So I'm going to do the back parentheses first. I'm going to treat that as a negative 2x times x is going to be negative 2x squared. Negative 2x times negative 1 is positive 2x. So now I have to lobster claw this first part. 3x squared, positive 16, or positive 18, let's see, that'd be positive 16, yeah, minus 12 equals 103. I am going to do the smart thing, and I'm going to bring 103 over here, put it at the very end, I'm going to subtract 103 and set it equal to 0. Now, let's simplify and clean this up. It looks really, really complicated, but 0 turns out to equal, well, here's 3x squared, find your like term, minus 2x squared, so that gives me x squared, plus 16x plus 2x, I believe that's plus 18x, minus 12 minus 103, I believe that's minus 115. This should factor. Okay, x and x, what multiplies give 115, that subtracts to be 18. Got to figure that. All right, I think I figured it out. I think 5 and 23 subtract to give me 18. So it's going to be 5 and 23. The bigger number wins the sign, so positive 23, negative 5. If I split and solve, I get positive 5 is x and negative 23 is x. Now, it turns out that it's going to be 2 times x, so I can't have negative, so I will simply discard the negative 1. So apparently my x value is 5. Now, let's make sure what we're asked to find. What are the dimensions of the inside rectangle, which means I want to know how big this one is. So I need x minus 1 and 2x. So if I put a 5 in here and a 5 over here, I should get 5 minus 1, which is 4, and I should get 2 times 5, which is 10. So the inside rectangle must be a 4 foot by 10 foot inner smaller rectangle. All right, that is your review of geometry related problems, and then the next ones would be ones for you to practice.